Okay, in this lesson, we're going to do one last thing with our debuggable type, and that is we're going to change it so it's going to use a list instead of a string. And what I mean by that is that when we look at this message right here, it's currently a string from the last videos. Now we're going to change that to a list of strings right there. And there are a few motivations for this lesson. The first is that it's important to get comfortable writing wrapper classes like this. And as I noted in previous videos, that's because we're creating monads over here. And one thing I may not have mentioned very much is when you create a different type of monad, you're going to be implementing map and flat map however you need to for that monad. So there are different types or different categories of these. And that's why I want to change this from a string to a list so you can get comfortable with seeing how these changes are going to be made in map and flat map and elsewhere as we make this change. And that's because these methods are implemented differently for each monad type, and then we'll see how that affects our other code as well. I note here in the book that many of the lessons that follow will show more wrapper classes, but that was something I'm doing for the book. It's not going to be something we're going to do in this video series because what I'm doing in the book is I start going off and creating an IO monad, and then we create a state monad, and then we try to get those working together. But when we're working with Zio, we don't have to worry about any of that. So I'm going to go right from here where you're seeing how to write your own monads, and then we're going to start using Zio. And the key for all of this is that you'll now understand a little bit of how Zio is implemented because we are implementing our own types over here just like this. And then at the very end, I'm going to have one last surprise for you, so I don't mention that as another motivation here. So again, the goal here is to change the type from string to list of strings. So I'm going to come up here and start working on that, start making that change. So that's going to be a list of string. In the book, I changed this message parameter to the name log because I think that's more meaningful. And I'll just change that here. If you notice, the list of string is not having any effect inside the map method. The only thing that's having a change here is that I'm changing that parameter name to log. And I can change this one to log, and I can change this one to log. The only problem with that is that code right there is going to change because now we're working with a list of string instead of a string. So we're not going to be concatenating it like I did before. So we'll go back here, go over to the next page. And as the note right here, this has no effect on map. Changing that to a list of string, there's no changes inside of here. All I did was change that parameter name. And this change does affect flat map. So what that does now is it prepends the old log message before the next value.log. And so what I mean by that is we're going to have this log and get rid of that. And then we're going to prepend that to next value.log. And again, next value.log is now a list of string. This is the prepend method for prepending a value like this to a list like this. That's what we're doing right there. And that's actually all we have to do inside of Debuggable. And now, as I note in the book, this also starts to affect our F and G and H methods. So we're going to scroll up here. And I notice there's a difference between the book and what I have here. So what I'm going to do is delete G and H to start with. And then what we have here is that val result equals A times 2. That's the same. And then the difference here is this debuggable right there. So I want to get rid of that right there and replace that with a debuggable value. And so if I go backwards, a key here was that I was having a debuggable before with that result and message. And now, as you can see, I still have the result. And now instead of a message, I am passing in a list here. And this particular list has this message here. So I'm showing the F function is multiplying A times 2 to get that result right there. And now, just as before, G and H are going to be similar to F. So I'm just going to do some copying and pasting, and I'll be right back in a moment. And I believe I did those correctly there. We have F and F, G, G, and H. Oops, I forgot to change those. So that's going to be 3, and that's going to be 4 right there. So now those are all done, I believe. And one thing I want to note is in the book, I noticed up here, where was I? I had that debuggable of int right there, and I was like, what am I doing there? One thing I skipped in the video lesson is I didn't cover the lesson on making debuggable generic. So that's why I'm showing debuggable of int right there. but I'm not doing that here because I have not made these parameters generic, or specifically, I have not made that a generic parameter yet. And I don't believe that's worth getting into right now, so I'm just going to go ahead and continue here. If you want to make that a generic parameter, what I was going to say in one of these lessons was that I was going to leave that as an exercise for the reader. Since we've already done that before, I think that's something that you should be able to do on your own, so I'm just going to leave that the way it is. So I changed F and G and H. I changed the debuggable type right there. We have the for expression here. And then what this really is going to affect also is this final printing right here. So I'm going to copy that. And the first print line statement is going to be the same. And then the second one is going to look like this. So what we're doing is we're getting this final result from that for expression right there. Then we use that here. We get the log parameter off of that. And that log parameter is this list of string right here. And then we say for each line in that log, go ahead and print that line prepended by the word log and the colon right there. So that's what that's doing right there. So I believe that should be everything. Let me save that and then come down here and run that. And no mistakes. Good. So I come back over to the book, and a couple pages later, we should see a result like that. The order is a little bit different, but you can see again, our value is 2400. And now the log is printing one line at a time. And I think this is really cool. It was a simple change, but I believe this is more of a real world change, keeping log messages in a list. And a reason I say that is because I think you saw that I was fighting with new line characters in previous videos as far as where to add them to try to make the string look good. And here you don't have to worry about anything like that. You just put the log messages in the list and then you print them out like this when you're finished. And that is much easier to work with all around. Thing I noted in the discussion here, this was a relatively minor change, but it was nice to see how that change had a ripple effect on our code. So we changed that right there, and that made us come back up to F and G and H and make these changes on that line specifically right there. And then when I scroll down, of course, then we had this for H change right there, but the rest of the code stayed the same. And now the surprise that I promised you is that what we just created is something known as the writer monad in Haskell. So I tried to sneak this one in here, and I think as you saw, everything we were doing was pretty standard coding by now. If you saw the original sequence class where I created the map and flat map methods, and then the wrapper classes, and now the debuggable, you've seen me go through this process several times now, so hopefully you're more comfortable with implementing these methods right here to get for expressions to work like this down here. And again, as I mentioned here, what we created is known as the writer monad. And I have a quote from a really good book. It was called Learn You a Haskell for Great Good. And it states that the writer monad is for values that have another value attached to, and it should say to the original value, that acts as sort of a log value. So writer allows us to do computations, and we were doing really simple computations up here, but we were making sure that all the log values are combined into one ongoing log, and in this case, a list of string right there. And then the ongoing log gets attached to the final result, and that is exactly what we have right in this area right here and right there. So that's really cool. This is what, maybe the second or third monad we've created by now. And hopefully you're starting to get comfortable with what we're doing. So in Scala, and I need to be really clear about that, in Scala, a monad is a class that has properly implemented map and flat map methods, along with some type of lift function, as is noted right there. And in our case, we have a properly implemented map method, a flat map method, and then this area here works as our lifting function. This is what allows us to lift ordinary values into our wrapper. If I use that term wrapper again, we lift these values into this code here, which is our wrapper, or more accurately, our monad. And if you followed along on the previous videos from the book, the way I had to do that in Scala 2 was I implemented the lift function in the apply method of a companion object. But with a case class, you don't have to do that. And just to repeat that, this area works as our lifting function right there. And so again, when I come over to this bullet point, at some point I would get away from the term wrapper because they become much more than just simple wrappers. what happens is every time you create a different monad, so if you can imagine that this one is called a writer, you can imagine that there's probably one called a reader. So the difference between those has to do with the map and flat map implementations. Every time you write a different monad, you're going to have different versions right here, and you're also going to have different types of lifting functions right there. And another thing you run into that I did not stress enough in this first book was that performing operations in sequence also becomes a key as you go farther along here. And this is difficult to show, so just give me a moment or two to try to set some things up here. I believe I mentioned this in previous videos, but a real key that kind of really hit me in the head really well was when I learned that the Haskell compiler is capable of doing everything in parallel. So if you have three expressions like these three right here, the Haskell compiler is capable of optimizing those and saying, you know what, Mr. Programmer, I'm going to go ahead and take these three and I'll run this one in parallel and this one in parallel and this one in parallel. And the problem with that, of course, in our situation is that this result here depends on that result. And then H result depends on G result, which depends on F result. So if these things are run out of order, those three expressions, that becomes a real problem for us. And I think I showed that earlier when I had statements like this. So I was showing something like print line, what's your name? And then we had val name equal read line. And then I would write print line and say, your name is $name. To me, this is even more apparent that this is going to be a problem. If the compiler can run these three expressions in any order, it's possible that it will do something like that, or even something like that, and then your code just isn't going to make any sense. So another benefit of what monads do is they ensure that the code that's run inside of for expressions is run in the proper order. So if you imagine that the Haskell compiler can run these in any order and the Zio interpreter can run those in any order, a cool thing about the for expression is it says, no, you can't run those in any order. You have to run this one first, then you have to run this one second, and you have to run this one third. That's another really big key about monads. And some people refer to monads as the semicolon in functional programming. And that's part of the reason is we're saying you have to run this one first, then this one, then this one. And we can see that anytime we go back to this desugared code. So if this is our for expression, when we go back to this desugared code, we can see that what the monad and the map and the flat map are forcing is that these have to be done in order. So this has to be done first, then flat map is called, then this has to be done second. Again, flat map is called, and then this has to be done third, and then the calculation is done at the end. So this part is another key about monads that I did not include in this other description here. And therefore, in a future version of this book, I am going to include a little discussion right here about everything I just mentioned. That if the compiler is allowed to do things like this in parallel, then a big key about for expressions is that they force the compiler to do things in order. And then the last thing I'll say is that I have some pretty good references here. So way back in the day when I was struggling to learn what a monad was, these were some of the best resources I found. So I haven't checked to see if these are still on the internet, but I will check them. And if they are, I will include these links in the description that goes along with this video.